Hello, welcome back. We're going to cover something called rationalizing radical denominators. This is actually something I've taught you as we have done a lot of the lessons on adding and subtracting radicals and multiplying and dividing radicals. So you already kind of know this, but we're going to expand on it a little bit. And basically, the bottom line is when you have something that has a radical in the denominator like this, we basically never want to see that in math. I mean, this is a valid number and all. It's just that we just generally don't like to see these in the bottom. So if you leave your answer with a radical in the bottom, you might get some points taken off. And you want to get rid of that. The process of getting rid of this radical in the denominator is called rationalizing the denominator. It's just something that we do in math, and you just have to kind of get used to seeing that you don't want these radicals in the bottom. Now the good news is there's a bulletproof way to do that. So you take the 1 over square root of 2. The way that you do it is you multiply what you have times the radical that you have in the bottom over the radical that you have on the bottom. Now, as I've said in previous lessons, what you're doing is you're multiplying the original problem by 1, because this is just root 2 over root 2, which is just 1. So you're not really changing the value of the original thing, you're just changing the way it looks. Now let's take a look at what happens. When you multiply the tops together, because these are just fractions, you're going to get square root of 2 on the top. And on the bottom, what are you going to get? You're going to get square root of 2 squared. Square root of 2 times square root of 2, square root of 2 squared. Now, the square is going to cancel with the square root, so what you're going to have in the bottom is a square root of 2 over 2. So that's the answer. Notice what's happened is, let me go and circle the answer. We went from this, which is the original problem that had a square root in the denominator, to this that does not have a square root in the denominator. These two things are equal. They're the same number. If you punch them into a calculator, you're going to see the same answer. But this one does not have that ugly radical in the bottom. We kind of moved it up to the top effectively. And so we call this the rationalized form. The denominator is rationalized. So when you see anywhere in a test, rationalize the denominator, that's all you're trying to do. And the way you do it is you always multiply what you have times the denominator over itself when you have these simple problems. We'll get into some more complicated problems in a minute. Now notice when we multiplied them together, I wrote it like this, but really you can think 2 times 2 is 4, so the square root of 4 is what you would have when you combine everything. Square root of 4 is 2. That's another way to think of it, but another way to think of it is square root of 2 squared, and so you can cancel with the radical there. Let's do a few more. You'll get the hang of this as we go, and we're going to get into some more complicated problems also. Let's say you have 3 over the square root of 6. Now you don't like that. You want to rationalize the denominator. So you take what you start with, 3 over the square root of 6, and you multiply by what? You multiply by that ugly radical that you don't like over itself. So you're multiplying by effectively 1. Now in the tops, 3 times the square root of 6, you can't really go any simpler than that, so you just keep it as 3 times the square root of 6. But on the bottom, again, what ends up happening here is it ends up being the square root of 6 squared. Now you have a square that cancels with the square root, so in the bottom what you're going to have is 3 root 6 over 6. Now this is the correct answer, but then you realize that, see, this is all multiplied on the top. You have this 3 out front and the 6 on the bottom, so you can simplify this. 3 divided by 3 is 1, 6 divided by 3 is 2. So on the top, this 3 kind of disappears into a 1, and what you'll have on the top left over is square root of 6, and on the bottom you'll just have a 2. That would be the final answer. If a student left this as the original answer, 3 square root of 6 over 6, I probably would count it correct, but this is the most simplified version of everything. This is what you're going to strive for. Notice that the